And welcome guys to another little tutorial. Now today I wanted to include a little bit of other stuff, okay? Because as you can see, I've been working on a little bit of a script here that is going to be managing our main game logic. But, that's how it goes for now. So I'm gonna delete some of this because we don't need that. Because I'm the type of programmer that believes one script needs to do one thing eccentric. I can't say that word. Just very, very well. If there's an initial load type function that you need or whatnot, let's put that in some form of logic to do that heavy lifting when it's needed instead of throughout the game here and there, and then we can hit bottlenecks. And I introduced you to a lot of different concepts and a lot of different kind of behaviors for weapons and vice versa. So we're going to get into what I believe is going to be very strong in my next little tutorial series. And it's kind of like the strengths and weaknesses of certain types. See, we dealt with inheritance. We dealt with scriptable objects. Now I wanted to get more in depth with interfaces. Now, we're going to pop over to Unity and do our nice little window thingy. Okay. And doop. And it wants to be done. Okay. There we go. Sorry about that, guys. And in this little script that we have here, not this, not this, not this, which these are okay, but I want something a little bit more centralized. You see this script right here? I wish I could make it bigger, but I don't have anything for that right now. Start game, in game, in menus, saving logic, spawning, and things. See how it's all nice and easy, and each one of these values has its own little things that you need to set up. Okay, like level loading, it's got a reference to this, it's got some type of parent. Then we have objects, and this is all in one major, like, let's say this is like basically your central script where everything else is like children to it. So you'll have this script here, and then this is another script that's basically like reference, but it's not actually just a reference. Now, there's a difference between a script like this and a reference like this that you just drag over. This exists in this variable here because it's a script for it. It's like a pure class, okay? And we'll get into that in a little bit, but I wanted you to see that this class will always exist. This isn't just a reference, except this game object, because it's just a game object. But this variable timer is for this, and then your URL. This is something that exists all the time. It doesn't have to be instantiated or nothing, but I wanted to show you that you could do this like this for one reason. Okay, so in our scripts, which I'll be swapping back over to now, we will see different types. Now let's look at this on start. We have a scriptable system.serializable. This is so that it will show up in the inspector. If you do not have this right here, this script will not show up in our inspector. This is our main class. This is just basically this script, but stuck in a variable, okay? And these are private because we don't have to access these at runtime at all. What I'm going to do is use this static pointer right here and use this to trigger callbacks that we need. Basically, we're going to have functions in here that are public constructors, which we've talked about in other videos and things. I believe it was in classes. But anyway, we will use our static that goes across many that can call all the functions that we need. So if we need something from our private variable, like what level is loaded, we can go into this script. Let's do the start thing right now. Okay, let's say we need this game object right here. Well, all we need to do in our manager class is find a nice little line. Let's say we need to get a game object. So we'll just make this public game object. Game object. And we'll call this start obj. Need to type, and what this can do is this would be the constructor that we would call, right? So we automatically have to return something. So what we'll say is return on, not on starter, but our variable name, which is start game, okay, dot game mode, okay. So we now have a function that's publicly accessible in our static function, and we didn't have to go into any of these classes and some other thing. So basically, when we go to write it in another class, like let's say in our weapon class, all we have to do, and this is just an example, is come down here and go game object go equals, because maybe we need to pull out a bullet or something or whatever, but we need that game object from on start. We just go into here, game object, then we would go game managing dot manager dot what do we call that again? The name for start obj? Okay. Dot start obj, and it's basically a function. So with this little bit of code right here, we're just going into our static instance and pulling up the game object that we want, our start obj. And we use a constructor like this to do the heavy lifting for us. And the thing about this is, let's say I delete this weapon script. Well, because it's coming from a static reference and it's a constructor like this, if I suddenly, let's say, delete this managing script, yeah, it'll give us an error and it'll go, hey, managing doesn't exist anymore. That's the only thing that I have to change in every one of my scripts. Okay, I'm not going to get these runtime things, not a runtime error, but it'll be a compiler error. So I know where every single thing is that I deleted. And this is very easy to track down. Where if it was a runtime thing, then yes, it would give us a problem, but the pointers would be a little bit harder to track down. And two, this is easy to read. Okay? This is a lot easier to read for me. We're going into a manager, start, OBJ. Okay, and we can go in and go seek reference. Okay, and it brings up the constructor of this, which I'm not too sure if it actually shows. Yeah, it'll show the window. Okay, that's great. So it shows the constructor and it shows me what's going on here. Okay, very easy to track down versus this big old long function that goes into another class, which could kind of suck. You know, I mean, if you got to do this big old long line, then it's going to be problematic for you. Where returns from startGame.go. Well, startGame.go is up here, start game, and we can always go into the starter script, which is right here. Oh, and we pulled this game off. Oh, that's great. Easier to track down. Now, in the past, we've used inheritance and things, but we really haven't talked too much about interfaces. The reason is a lot of people like inheritance, but there is a strong type of use for interfaces as well that you cannot do with inheritance. Okay, now let's talk about this sensibly. Inheritance is great for some things, overriding and a lot of other things, but interfaces have one thing over it. If I want to use this mono behavior and I want to inherit from a different thing, I cannot. So this onStart right here from the game object, this is an interface. But the great thing about interfaces is you can have multiple interfaces. Where inheritance, you really can't. You have to inherit from one specific thing, a base class or another type. It's really just one single thing, which kind of sucks. So if I wanted to take this main, let's say game off, this logic right here. Ooh, or no, here's a better example. Okay, we have this game logic right here, which is an interface, and I don't know why I put it null because it always exists. But anyway, this exists right here. This is an interface. Well, when we're doing our interfaces, what I'm going to do is use this variable, pass it in so it can be equal to this. Well, when the update is running, it's going to be running in our interface. Like I said, we're going to use the interface for multiple things, right? So we're going to go up here and say, hey, this is our game. Well, this is our update, but because it's not a mono behavior, it doesn't exactly, this is an onStart, on update, this, and if we didn't have this in here, we wouldn't have an update at all, okay? So we can delete this and be just fine. We might need to start or whatnot, or await. But anyway, getting on to the point. In our managing, we're going to go game dot, and we will have access to onStart dot on update. And these are functions, just like we did in inheritance. Okay? And this can be our main game object, just basically main loop. But because we're using this single variable here, these other ones, they're not getting ran unless they have their own logic in there, like start and update and things. The only one we're launching a update to is this game one right here. Which brings us to the really good thing and the really bad thing about inheritance. Okay? And interfaces suffer from the same thing. This game logic right here, let's take a look at the definition of it by itself. Because this is an interface, I only have access to these functions. When I declare a variable like this from game logic, the game logic script, all my other classes must have these functions in them. Okay? They must have them in them. They can have each script that inheritance from that integrates has the interface on it. These have to exist, and when we declare the variable like this, I only have access to these functions. Even though my onStart could have many functions in it, when I go to this variable right here, I can only call these functions right here. I hope you get what I'm saying. Basically, I'm limiting myself. Think of it as game logic. I only have access to the public functions from game logic. Even though I can put this onStart in the variable of game logic because it's an interface, just like I would with inheritance, it will only have access to game logic functions. Okay, even though these these have the interface or inheritance in them, I'm limited to the functions. Okay, but if I have these variables right here, whatever this variable right here is, I have access to the functions that's in there. So basically, when you use this script, you only have access to these functions. If you use onStart, you will have access to onStart's functions that are public. And if onSave has 100 different functions, then when I use the onSave variable like this, then I have access to all of them. It's just like this game object return thing. This function doesn't exist, but if you look at how I declared it, we have our static, okay? I went to the manager and was able to just pull it out because it was used publicly in the right type of script. Basically, the variable right here, this right here, changes everything. And I hope that makes sense. I wish there was an easier way for me to explain it, but it's kind of one of those gray areas. Once you start messing with them, you will get it. Trust me. Play around with trying to write into a variable like this and write into this. Now, here is the very strong part about using interfaces that is really nice. Is inheritance cannot do this. You cannot inherit from mono behavior here and then inherit from something else. Okay, so it kind of is weak sauce, right? So, in our OnStart, we've got this logic here, but because this is an interface like this, and instead of inheritance, we can do something completely different. And this is the strength of it. In my level loading thing, I have mono behavior and my logic. I can grab the mono behavior and my interface both. Where in inheritance, I can't. So I have everything from the mono behavior, including attaching it to a game object, and I have an interface itself. Now you're like, why would this be useful? Well, here's the thing about it. It's useful if you want to limit certain things. Let's say you have a class of the type health, okay? And the class of taking damage. You can use interfaces to make sure classes only have access to, it's like namespacing. If the interface is not there, then I can't access anything that uses the interface. It's like limiting your code. But at the same time, you get the benefits of this. Anything that integrates the interface, you can reference inside of a variable like this. So game logic, anything that deals with game logic, I can stuff in this variable, which is really nice. So if I want to stick a spawn thing, well, it integrates an interface. All I gotta do is call a function in it. Boom, there you go. Saving. Yeah. But this on-level loading thing is its own little script. Well, it's a mono behavior, so I can attach it to a game object, and it can be fine. But when I go up to here into this game logic variable right here, I can stuff this script in here and still get all the effects that I want. Where in inheritance, I can't touch anything from the mono behavior. Which mono behavior does a lot of cool things. You get coroutines that's written because if you don't inherit it and if you don't use inheritance to inherit from, like, your parent class has got mono behavior, and then you inherit it from the on-level load. If you don't have any form of mono behavior being inherited from the class, then you can't do invoke repeating, because it comes from the mono behavior stuff. Okay? And the good example of this is if I'm using inheritance and I don't have this mono behavior here, when I go into update and not update, but it's on trigger enter, exit, and all the mono behavior callbacks that are not specific to C#. Like, if I don't have this mono behavior here, on trigger enter, on trigger exit, on level load, a lot of functions do not get called because they're not actual functions unless you inherit from mono. Mono behavior has a lot of callbacks that it does. Like, let's say you're doing the new Unity networking system. You have to inherit from the networking. Okay, it's not mono behavior, you're inheriting from the networking. And then the networking inherits from mono. You see what I'm trying to get here? If you're going with a pure class that's like this, everything from the mono behavior callback system and stuff does not get called because it doesn't exist. And that is the very, very good thing that, because mono behavior is a base class for every drive, every script drives from. It's got a lot of callbacks and stuff like that that you need to be aware of. And anything that deals with on collision enter, if you don't have mono behavior here, or your inherited class doesn't inherit from mono, doesn't work. You had to write your own collision, which could be a pain for you. So in this lesson, the thing that I want you to take from this is interfaces can have multiple things of this. The mono behavior has to be first, then all your interfaces, so the callback system does what it needs to do. But like I said, it depends on your game and what you need. Now, I'm not saying this is the perfect solution for you. I'm not saying that this works in every case. But I want to make you aware that you can do this so that you can run into cool stuff like this. Variable, we can get away with a pure C class, pure C class, pure C class. Oh, wait, I need something from the mono behavior for let's say the UI system. Oh God, now I need mono behavior, but I used inheritance and I just can't fix this with inheritance because I have to inherit from mono. So if I wanted it, I would have to change every script. Oh my gosh, that would be double plus very, very bad for you. Because sometimes you need a pure class instead of a mono class. You see what I'm getting at? You can shoot yourself in the foot if you're not too careful. So, pure class, pure class, pure class, pure class, pure class. Oh, well guess what? This is a mono class and I need this. But if all these, let's say game logic right here, was not an interface, but an inheriting class, then you got to do all those overriding and this and that, and it becomes very messy very quickly. So keep that in mind. And yeah, just keep that in mind, because you are going to need multiple different things when you're programming. And the great thing about an interface like this, let's delete this because we don't need it in here, because I'm not using it in that form. When you have an interface like this, the interface's functions must be in the script. Okay? If you do not have these in the script, you get compiler errors. It won't show me in here, but when I go back to Unity, I have the interface here, but I'm not using the interface. I do not have these functions inside of my class. So, which was it? On level load. It's got mono behavior in that, but it doesn't have what we need. So, and this is the thing I like about interfaces, is if I go into Unity, I get these errors. Okay, on level load does not implement interface member game logic.onStart. It doesn't have those functions inside of it, so it just wrecks my compiler and just like, oh no, I can't do it, I'm sorry. Well, if you go in and integrate those functions inside of your script like this, it will give you awesome uncompiler errors. And the thing about inheritance that I do not like is if the function doesn't exist in the class, it doesn't really give you any warnings, really. I mean, it does give you a warning, but it won't error out. It won't give you a big old error and go screaming at you going, hey, this doesn't work, stop doing this, blah, blah, blah. It's private, you're not supposed to do. You know, it's not, it just doesn't give you as much information as I would like. So keep that in mind when working with inheritance versus the interface class. And all you had to do is right click or just write them out. This throw system exception thing, it's just to give you errors and stuff if you try to use it. You know, if you have your program running and stuff and it doesn't act right and things, it's because of an error. If it doesn't like throw out a console problem or just scream at you, hey, you messed up, then it's going to really suck to try to debug. A lot of times I don't like to use if statements. I'll just let my program crash. If I, like, let's say this on level load method, I had the start, update, and things like that. Well, if I don't have the start method here, the interface will give me a problem. And I'm okay with that. Because when I'm using this manage logic, I'm going to have probably a callback system for going when I make my game. Just when I stuff it in this variable to make it run and do what I need to, when I stuff it in this variable, I'm probably going to go game dot on start, right? And run the start functionality of when I need it. Okay? Because maybe my start functionality will resize my character what it needs to be, or let's say it pulls out my weapon, or you know, it instantiates some particle effect because I start running and I'm like just giving her all, or maybe it's to check in one of my bulls to go, hey, this is running, do something, you know. And because this is stuffed in a variable like this, every single time I change this variable to start, on game, in menus, save, spawn, these all have to run beyond start unless I do a custom call for each one. You know, from if I'm in menu, the in-game, and I go to menus, I may not want this to run the start method. I may want it to do something completely custom, which is okay because I'll probably use a constructor from this class to do something instead of going through a bunch of loops and stuff. You know, just, and this main class has access to, if I, let's say every single one of these classes, I need to stuff a variable in here for the main game logic. Okay, like game logic. Or, oh, managing. Oh, this will be a good one. Okay, which is fine and everything, but what I'm going to do, instead of going into every single one of these classes, I'll go into start, and I'll make a public variable. Now, I like to use this little line right here every once in a while to indicate certain things, like I don't want myself to access this in another type of script. I mean, a lot of times what I'll do is I'll make a constructor, in which I probably will make a constructor for this, but this is an example. So we're going to go into our game manager script, okay? Well, in my main start, when this game goes, and it does all that logic stuff, like, let's say it loads up a previous file, or it instantiates like dropped items into the world that I may have dropped from a previous game, or my score, bullet shot, things of that nature. Okay. I can always go in here and go we need to go into start game. We've got a variable for why does it do that though? Not exactly. Huh. That was weird. Game manager equals this. Okay? And this is something that you can do. And I can go through and do this dot in game dot UI equals this dot game object. And I could sit here and assign all those things that I need done right off the bat. Okay. But in the meantime, what I like doing a lot of times is if I need to change the state from, let's say, whatever this game thing here is, and I want it to go to start, a lot of times what I'll do is I'll make a constructor that will do that. Okay. It'll be like a public thing, public void and this is a variable thing. It's not really a function. So there you go. And then I'll go game dot on start, which is a function. And bam. These type of functions inside of my class. Now, you're probably like, well, in your on start method, you have access to the manager. Why don't you just do something directly? I don't want to do that. I want to keep that type of functionality someplace else. Because here's what could happen. Let's say you've got a button. In the up state, you want the player to float in the air, maybe 800 feet or something. Okay? But in the down state, you want him to smash into the ground and kill themselves, right? Well, that's two different logics right there. Okay? Well, in the spawning state, maybe you want him to spawn up in the air at a random location and smash into the ground, or other types of stuff. Well, instead of going and doing game manager dot game and assigning it directly, you can go in the game manager dot start game state and just call it. Okay, so when you call the start, it's a very simple line. You know what's going on in that line, and it becomes more easy to debug. Because if I go in there and start assigning references to go to certain places, well, guess what? Then I'll probably have to do the same thing multiple times. I can easily see us having to go to the spawn state a lot. Okay, so why not have a constructor in our main game manager that does the spawning for us, keeping us from making these big old, well, spawning actually is a good is an actual good example. Because if we do a spawning and we assign variables and stuff like that, then we're going to have a reference to our player somehow, which could be tricky. Because my health class, it just needs to know when my health is below 0 and we die. Well, if we die, then we go to the spawning state. And then the spawning state, after I spawn into the game, it should go into the in-game state. And then we have, let's say we're in the menus and we want to go into the in-game state again. There's two different classes that want to do the same thing. So a constructor to go into the in-game state where we're running around and stuff would actually benefit us, because A, easier to debug, B, it does one job. It does the job of pushing all that logic out of smaller scripts like on game on game. What's that do, right? And then you got to hunt down what it actually does, okay? Which kind of sucks because level loading, it shouldn't care about anything besides level loading. If it needs to go to a different, like, managing spot, then I should just push a constructor to make it do something, okay? Making constructors do what you need versus writing a single line of code inside of a class to do something, you've got to be careful about it. Because this start right here shouldn't have to be assigning variables in here and going, hey, spawn something, okay? Or load main menu or anything of that. If I wanted to load the main menu, what I can do is have my own custom constructor in here. And the great thing about this is I can go into any one of these classes and go, well, my level load is not a public, is it? In my managing class. No, it is not. And why is that? Should we actually have a public? And the answer all depends on our game. But it's like I always say. If you can simplify something, do it, because if it's simpler to read, it's faster to debug, it's easier to debug, and when you know where the logic is for that particular function, like here, if I assign something very, very, very wrong, then I know it's here, not in here, 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 here. Like this public constructor right here. I may need 5 or 6 scripts to get this game object. Which, I mean, it's not exactly wrong, but it's easier for us to use. And I hope this opens up the window to you and you get something from this video. If it's a little confusing, I'm sorry, because there's no easy way of saying it. It's just one of those, I'm going to expose you to that and you experiment with it, and after so long of experimenting with it, you'll understand it more. Trust me, you'll get it after you messed around with it enough. But I'm gonna cut this video and try to do some other stuff for you guys. But I hope you learned something and try to take care of yourself and don't get frustrated. Well, it's inevitable, but still. Don't give up and just don't degrade yourself. You can get it. It just takes a while. It took me a while to get it. I was sitting in class for a couple days and I started seeing it after that. So research it as well, but don't let yourself give up. If this is something that you want to do it. Thank you for your time. And this is YouTube. Hit like, subscribe. Thanks for your time, guys, and appreciate it. But peace out and keep on trucking and keep on pushing.